Hello Year 10. Today we're going to be looking at salts from insoluble bases. You can find information on this in pages 92 and 93 on the digital textbook, the AQA version. You can find on Caboodle. You can also look for making salts on the BBC Bite-Size website. Please have your exercise book with you. I will be asking you to pause this video at various points in order to make notes or work through problems. Without further ado then, let's get stuck straight into it. First things first, I'd like you to have a go at this little starter to get warmed up for some learning. There are 6 compounds listed. Please can you have a go at naming these compounds. As some hints, OH is hydroxide, NO3 is nitrate, and SO4 is sulfate. Have a go at these 6 compounds here. Please pause the video, writing it out in your exercise book, and you can unpause it and we'll run through the answers. In terms of the answers, number 1 is sulfuric acid. Now looking at this, you could call it hydrogen sulfate. That's a perfectly acceptable answer. However, for reasons that we'll see, it's far quicker and far easier to call it sulfuric acid. In terms of number 2 you could call it hydrogen chloride, or you could call it hydrochloric acid, for very similar reasons to the first one. For number 3, you could call it nitric acid, or hydrogen nitrate, but nitric acid is the name that we use most commonly. Numbers 1 to 3 all have something in common. They're all acids, as we'll see. In terms of compounds 4, 5 and 6, these are all bases. The first 2, 4 and 5, are actually hydroxides or alkalis. So number 4 is sodium hydroxide and number 5 is potassium hydroxide. Number 6 is an insoluble base called calcium oxide, CaO. Hopefully you got those right. Let's look at this in a little bit more detail. But did you know that way back when in 1949, a man called John Haigh became known as the acid bath murderer? Now, he tried to kill loads of people and get rid of their bodies, and he successfully murdered them, but he tried to get rid of their bodies by putting their bodies in a bath of really strong concentrated acid. And in many instances, he was successful. However, he was caught when the police found some leftover bones, false teeth and gallstones, which is rather interesting. So bones and teeth are what saved the day, and ultimately he was hanged in 1949 for his crimes. So the big question for today's lesson is, how can we get a clean, dry salt from an acid and from a base? So I'd like you to pause here for a moment, have a think about the key terms from this big question, write it out in your exercise book and underline the key things from this question. And I'll pick up where you left off once you've done that. Okay. For me, the key terms will be clean, right, dry, salt from an acid and a base. So the first 2 terms, clean and dry. Clean means free from impurities and dry means not wet. And that's important because people often forget that the sample needs to be pure and also it needs to be not wet. Okay, moving on. If we think about these various different acids, we've got hydrochloric acid, which we found out is HCl, sulfuric acid, H2SO4, nitric acid, HNO3, phosphoric acid, H3PO4, and ethanoic acid, CH3COOH. The first 4, as we'll find out later, are all commonly called strong acids or mineral acids. Ethanoic acid is an example of a weak acid. Have a little think, what do they all have in common? Pause the video and we'll pick up in a moment. So hopefully you've noticed that all of the acid formula have in common that they all contain hydrogen ions. They all contain hydrogen. In the case of hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3, phosphoric acid, H3PO4, and ethanoic acid, it's actually this last hydrogen here which ionizes. That is why that's known as ethanoic acid. Now, so we can add to our big question, and acids all contain hydrogen ions, and you might know that they also have a pH less than 7. Pause the video and just jot that down as part of your big question. So we need to now think about bases. And bases are substances which react with acids. All bases react with acids. However, there are several different classes of bases. There are metal oxides, metal hydroxides, metal carbonates, and also ammonia. Now, there is a special subclass of bases called alkalis, which are mainly hydroxides. They're soluble bases. They dissolve in water. Bases such as metal oxides and metal carbonates tend to be insoluble. They don't dissolve in water. So alkalis, they produce hydroxide ions in solution, and these are examples of the metal hydroxides such as sodium hydroxide or potassium hydroxide, and also ammonia. Here are some hydroxides, some alkalis. Lithium hydroxide will be LiOH, sodium hydroxide will be NaOH, potassium hydroxide is KOH. Ammonia is also another alkali. That is a gas NH3 that dissolves in water to form an alkaline solution. And that occurs via this reaction here, where ammonia reacts with water to form NH4OH, ammonium hydroxide. And those hydroxide ions are why ammonia is classed as an alkali, right? It's also classed as a weak base, as we'll see, which means that it only partially reacts with water. Let's go back to our big question and see now if you can add a definition of a base to your big question. Pause the video and do so now. Okay, so as part of your big question now, we've got the fact that we're going to prepare a clean and dry sample of a salt. We haven't yet covered what a salt is yet, but we will. We've said that an acid contains hydrogen ions and the substances that have a pH less than 7. Bases are substances that react with acids and they have a pH more than 7 on the pH scale, greater than 7. Metal oxides are bases, they're insoluble in water. You could also add here metal carbonates, and metal hydroxides in general, alkalis, they're soluble bases, a special class of base, because bases in general are insoluble in water. Salts then, this is the last part of our big question. What on earth is a salt? Well, when you react an acid and a base, you form a salt. And a salt is a substance where some or all of the hydrogen ions in an acid are replaced by a metal ion or an ammonium ion from the base. That's the definition of a salt. Pause the video and add that to your big question, please. Different types of salt can be produced depending upon the acid that you've used as well as the base. So hydrochloric acid will produce chlorides, sulfuric acid produces sulfates, nitric acid produces nitrates, and also phosphoric acid produces phosphates. There are different formulae of acids that you need to know. You need to know sulfuric acid, H2SO4, and they form sulfate ions, SO4 2-. Carbonic acid, H2O3, forms carbonates or CO3 2-. Nitric acid, HNO3, forms nitrate ions, NO3-. And finally, phosphoric acid, H3PO4, forms phosphate ions, PO4 3-. So now we can add to our big question. This is what our big question looks like at the moment. We've talked about acids and bases already. Salts are formed when acids react with bases. And as we've seen, they have where some or all of the hydrogen ions have been replaced by a metal ion or an ammonium ion. In terms of a general equation for the reaction between an acid and a base, whenever you react an acid with a base, you form a salt and water. So here's an example of that. Hydrochloric acid plus sodium hydroxide makes sodium chloride and water. You can see to help you here, I've colour-coded various parts of this word equation. So hydro means hydrogen from the acid. Chloric refers to the chloride in hydrochloric acid. Sodium is a metal as part of the base sodium hydroxide. This is actually an alkali, and that goes on to form sodium chloride, which is table salt, the most common type of salt. You can see here that's a result of the sodium in orange here, right, reacting with the chloride from the hydrochloric acid, hence the colour coding here. The hydrogen from the acid reacts with the hydroxide to form water. Using this as an example, I'd like you to pause the video and complete the following word equations. There's only 3 of them. We'll go through the answer in a moment. So in the case of sulfuric acid reacts with potassium hydroxide to form potassium sulfate and water. In every case here, you're always forming water. The only thing you have to figure out is the salt that's formed. So if you're reacting sulfuric acid with potassium hydroxide, you'll form potassium sulfate. If you're reacting nitric acid with sodium hydroxide, you'll form sodium nitrate and water. If you're reacting sulfuric acid with copper oxide, you'll form copper sulfate and water. If you're up for a challenge, have a go at some extension by writing out balanced symbol equations for the above. To give you a bit of a hint, hydrochloric acid, as we've seen, is HCl, sulfuric acid is H2SO4, and nitric acid is HNO3, sulfuric acid is H2SO4, as we've seen. Take care with the charges on the ions to work out the formula. Okay, well done for giving that a go, because this is hard. This is certainly higher material. Hydrochloric acid is HCl. That reacts with sodium hydroxide, NaOH, to form sodium chloride, NaCl, and water. You'll notice how to help you understand this. I've colour-coded things, the elements, so that you can see where they end up. So sodium here is orange, sodium here is orange, chloride here is green, chloride here is green, and then hopefully you can see that the hydrogen reacts with the hydroxide to form water in each case. In terms of the sulfuric acid, this sulfate ion, will react with 2 potassium ions because the charge on a sulfate is SO4 2-. That means you need to have 2 potassiums for every sulfate ion. So the formula of potassium sulfate is K2SO4. You also form water as well. In terms of the nitric acid, that's HNO3. That reacts with the sodium hydroxide, NaOH, to form sodium nitrate and water. And the last one, sulfuric acid, H2SO4, reacts with copper oxide, forming copper sulfate and water. The next little thing that's part of our big question is going through the required practical, because our big question really is how to prepare a clean, pure and dry sample of a salt from a base and an acid. So from the exam board, the required practical is preparation of a pure dry sample of a soluble salt, that's a salt which dissolves, from an insoluble oxide or carbonate, in other words from a base, using a Bunsen burner to heat, dilute acid, and a water bath or electric heater to evaporate the solution. A water bath is where you take an evaporating basin and place it onto a beaker of hot water. I'm just going to show you it from an evaporating basin, but either is perfectly acceptable. Okay, the first stage in terms of the preparation of the salt is to take your metal oxide, your metal carbonate, your base, and add it to a certain volume of acid. So you use a measuring cylinder, you measure a specific volume of acid and you pour it into a beaker. You then warm it gently using a Bunsen on a tripod and add the base, stirring constantly until all of the base is dissolved. So you've added your spatula of base, either a metal oxide or a carbonate, into the acid, and you've stirred using this glass rod here, during this glass stirring rod. And you keep adding the base until there is an excess. That means in the bottom of the beaker here, you'll see excess metal oxide or carbonate. Not all of it will have dissolved. That's important because you know at this point that all of the acid will have reacted. Very, very important for the reaction. The second stage then is filtration, because what you'll have is you'll now have a solution with an excess of that base within it. Here we've talked about a metal oxide, but it could be a metal carbonate. And you pour, well, first of all, you need to fold your filter paper and place it into a filter funnel. And then you place that filter funnel into a conical flask, as described here in this step A. In terms of step B, you'll then pour your salt solution into the filter paper. Through the filter funnel it will go, and you'll be left with a salt solution left behind. And you've separated your excess base from the salt solution. The next stage is crystallization. That's where you take your salt solution, which you've separated from the base in the previous step, in the filtration step, and you pour that salt solution into an evaporating basin, right? You then heat that evaporating basin over a Bunsen gently, avoiding spitting, because the salt solution could spit, and that will mean that your yield will be lower, you'll lose mass. And you want to heat it until roughly a third of the original volume remains. You can then place this evaporating dish on the side to cool. In terms of drying, you leave the solution on the side to crystallize. When you do so, you'll end up with little crystals in your evaporating basin. Here's a photograph of one here with some copper sulfate crystals, this beautiful blue colour, which has been formed from the reaction of sulfuric acid and copper oxide. You need to make sure that the solution is dry, or the sample is dry I should say, by you can either pat it with filter paper or you can place it in a warm oven. Hopefully by now you'll understand this practical, guys. But on page 93 of the textbook is a nice purple box showing that this is a required practical. In this case they're making a copper salt from sulfuric acid and copper oxide to form copper sulfate, those beautiful blue crystals that we've just seen, and water. The first stage is the reaction where you add your base, in this case copper oxide, to the acid, to the sulfuric acid, and warm it gently. That step cannot be overstated. Please make sure that you warm it gently so that it doesn't spit everywhere, and that would obviously be a safety hazard. As ever with any of these practicals, you'll be wearing safety goggles. You'll see excess copper oxide left over. That's important because then you know that all of the acid has reacted with your base. You can then separate that in the filtration stage once the reaction is complete, leaving you with a beautiful salt solution of copper sulfate in solution. This is that next stage in terms of evaporation, whereby you'll place your copper sulfate into an evaporating basin and warm it gently over a water bath, boiling water here, and that will cause the excess water to evaporate out of your basin, leaving behind copper sulfate solution. The last step, but that isn't shown in this purple box, is drying the copper sulfate crystals by dabbing it with filter paper, as it describes here, then leaving to dry. You could also put it in an oven. If you haven't already drawn nice diagrams of these to show each stage, please do so. You can refer back to the previous slides by rewinding the video if necessary. These diagrams are fine, but my diagrams are better because they're in 2 dimensions, as they all should be, like that's shown in step 4 here. So please pause the video and go back if you haven't already drawn beautiful diagrams to help you to understand this practical. So in general then, guys, in terms of neutralisation and salts, and we'll look at neutralisation in a future lesson, I'd like you to write out general equations for the following neutralisation reactions of acids with these bases. So an acid with a metal oxide, an acid with a metal hydroxide, and an acid with a metal carbonate. Pause the video now and write out general equations in your exercise book. Okay, let's run through the answers for these neutralisation reactions. In general, for an acid with a metal oxide, when you take an acid and react it with a metal oxide, you'll form a salt and water. The same is also true for a metal hydroxide. Remember that metal hydroxides are alkalis, whereas metal oxides are insoluble bases. These are bases too, but they're soluble. And in that case, you also form a salt and you also form water. There's one special case of this, where you react an acid with a metal carbonate, you form a salt, water, and carbon dioxide. Carbon dioxide is also formed as a gas because you have a carbonate here. Remember that 8 means that this substance contains oxygen as well as carbon, right? Whenever you see a substance that has the word 8 in it, ATE, that means it contains oxygen as well as whatever it's bonded to here. In the previous lesson, which I have yet to video, but when we were in school, you'll recall that we added an acid to a metal, we form a salt and hydrogen. This is the difference to these previous examples here that we've gone through today, because there's no oxygen here, whereas there's oxygen in all of these other examples: metal oxide, metal hydroxide, and carbonate, 8 meaning that it contains oxygen. You form water. However, in this case, the bottom case, you're reacting your acid with a metal and the metal does not contain any oxygen, so you form hydrogen rather than water. So in summary, what have you learned? Hopefully you've learned what is an acid, what is a base, what is a salt, and hopefully you've also learned how we prepare a clean and dry sample of a salt from a base. To prove that you know this, please pause the video and answer the following questions in your exercise book. Okay, running through the answers for this. An acid is a substance which contains hydrogen ions. They have a pH value less than 7. What is a base? Well, a base is a substance which reacts with an acid. They have pH values greater than 7. Soluble bases are called alkalis, and they dissolve to form hydroxide ions. Hopefully you've also learned that a salt is a substance formed when some or all of the hydrogen ions in an acid is replaced by a metal ion or an ammonium ion from the base. And how do we prepare a clean and dry sample of a salt from a base? Well, there's essentially 4 stages. The first stage is reaction. You need to add excess base to ensure that all of the acid reacts. Then there's filtration, which is separating your excess base from the salt solution. And finally, in the next stage, the penultimate stage, you've got evaporation, where you remove the water by crystallizing the salt over a water bath. Finally, drying. You pat it dry with a filter paper, or you can place it in a warm oven. Thank you ever so much for your attention, and I'll see you next time.